Okay then, so question 3, page 358, final video of Unit 3, final video of the higher course. This is it, it's over, until they change the specification all over again, then I'm in big trouble. Anyway, question 3. There's a chap called Hamilton here. It says, let's work in black, it says Hamilton is given the graph of y equals some sort of function of x. He knows that the graph of y equals f of x minus 1 is a translation of the graph of y equals f of x using vectors 0, minus 1. You know that. Drop it down 1 unit. He says that the graph of y equals f bracket x minus 1 must be a translation of minus 1, 0. Is he correct? And explain your answer. Okay, here I go. I've got y equals f of x minus 1. Let's look at the original. We're looking at y equals f of x plus or minus a. In this case it says minus a, and what that means is we take the value of a and we move it in that direction by the value of a. Okay, in this case we're going to move the function to the right along the x-axis and parallel to it, and it will move to the right 1 unit. Now if we take a graph, for example something like this, which is y equals say x squared, and we move it in this direction by 1 unit, it will end up looking something like this. Alright, so it's been transformed from there to there, and the value of that shift is 1 unit. How would you write that as a vector? Well, let's change to blue. It's moved 1 to the right, and therefore it's going to be 1 across, and the graph isn't moving up or down, so it's 0. So that Hamilton is wrong. So what is the transformation? We're going to translate the function y equals generic f of x using the vector 1, 0 and not minus 1. Oh, sorry, and not minus 1, 0. Okay, classic mistake. People see the minus there and move it to the left. It's not. It's been shown from my original introductory videos that a minus function, a minus a embedded within the function, has the effect of moving the graph to the right hand side by the value of a. So translate the function y equals f of x using vector 1, 0 and not minus 1, 0, and that's what he's done wrong. Let's just turn over for the final question, and it is exceptionally boringly easy, and it's an AQA question set in 2009, and it's a whole 1 mark. Is it worth it? Let's do it. The graph of y equals 3 minus x squared is sketched below. Alright, so it's obviously a minus x squared because of the shape of the graph, and that coordinate there is clearly meant to be 0, 3. It is the maximum point on the graph, or it's the coordinates of the maximum point. It says copy the sketch on the same axes, and yeah, alright, and sketch the graph of 7 minus x squared. Well, if it's minus x squared, it's going to be exactly the same shape, but pass through the point 0, 7 instead of 0, 3. So what's happened? I've effectively, let me explain it in more detail. I've got the function y equals f of x, and I've gone from 3 up to 7. So really I've gone y equals some sort of function of x, and then I've added 4. Essentially I'm going to take this graph up to about here somewhere. It doesn't have to be accurate. I just need to do it carefully and label my key points. So here it goes. Let's just lift him up there, cross, and begin to come down again. And that point there is the new maximum of 0, 7. Alright, really important to label that point rather than just show that the graph has been lifted up in the air by some random undefined amount. So let's just label the equation y equals 7 minus x squared. Effectively I've gone from 0, 3 to 0, 7, so effectively I've taken the original function and then I upped it 4 units in the y direction, parallel to the y-axis. Okay, now that is a really easy question. It doesn't ask me to explain this, but that's the function. Let's just compare. Y equals 3 minus x squared, or we can call it y equals minus x squared plus 3. Okay, 0, 3. And then here I've got the function y equals 7 minus x squared, or y equals minus x squared plus 7. And clearly, to go from 3 to 7, I must add 4 units. To go from my original function to the transform function, I must add 4 units. And I've done an awful lot just for that one mark. You don't need to say all that. You merely have to copy the sketch on the same axes, and copy the sketch, and on the same axes you sketch the graph of 7 minus x squared. In other words, lift it another 4 units to the point of 0, 7, and that's the new maximum value. And that's it. We have done it. I will now sign the course off. Well, it's been very emotional. I hope you get the grades you're predicted to get and targeted to get. I hope that you work hard enough to exceed your targets and go on to do the courses you want to do when you move on from school. Alright, so this is Mr. Christou signing off. At your service. It's been a real pleasure. It's been emotional. It's been very tough. I've been working day and night to do these 540, 550 odd videos. I can't remember how many are on YouTube at the moment, but by the time I've uploaded this lot, I'm probably hitting 550 videos. We're going to have a look. Go and have a look and see what's up there. It will do you some good. Okay, so I'm signing off, and I'll see you in a classroom somewhere near you.